Hello, good morning. Welcome to the FHIR profiling overview presentation. I'm Mirjam. I work for FHIR, as you can see by my yellow shirt as well, but and some of you might have seen me already. I'm a FHIR trainer, so anytime you have a need for a FHIR training course and you reach out to FHIR, I'm one of the ones that you could encounter there. And I've been working together with Ewout since 2012 when FHIR had just started, and he initiated me in the first beginnings of it. So I'm taking over from my colleague Michel, who has unfortunately fallen ill. He was on the schedule previously, but they've changed it to me. So what are we going to talk about these couple of minutes here? So I've got about half an hour to tell you about FHIR profiling. It's just an overview, so we are going to cover some of the things like why would you need to do some profiling, or why do you need to know about it. I'm also going to show you what's in FHIR regarding the conformance layer, and then I'm going to give you some more details, and hopefully at the end you'll know where to go to next, because there will be other sessions as well that go into more depth regarding specific topics here. So first, why would you need profiling? If you know FHIR, you know that you have this standard, right? So we have a standard, it's a global standard, international standard. So within this standard, we need to be able to cover all kinds of use cases, wherever in the world you are. And that also means that we cannot put everything that you might need for your use case in the standard, and that makes for profiling. You will need to adapt what the standard offers you in order to be able to implement your own use case. So we need to describe extra things and adapt the standard that's there, the FHIR core standard, and then adapt that to our own use cases. Profiling offers you the way to do that. So if we are going to take a look at the FHIR conformance resources that you have, you can describe things like which resources do we use in our use case, which elements within those resources are used, and perhaps also which extra elements are added to the FHIR standard resources. Also, we can cover things like terminologies, how to map things to your own local requirements. So there are FHIR resources in order to describe all of this. The nice thing about this describing is that then you will have a set of definitions that are authored in a structured manner. And as soon as we have something that's structured, computers can work with that, right? So then you can read them in, and you can make use of those structures. You can distribute the structures so other people can make use of them as well. And you can use those structures, well, first, of course, to publish them, so you make other people aware that they are there, and then you can use them for validation, for code generation, and all things like that. So FHIR offers you a couple of FHIR resource types in order to do the profiling. We've got them separated into several categories here. Most important that you will probably encounter first will be the structure definition resource. The structure definition resource describes a structure. It also says element definition on this slide, but element definition actually is a part of the structure definition. I'll get into more details there later on. There's also something called graph definition, where you can define the structure, how they relate to each other in a graph. There's terminology types of resources, so you can create code systems, you can have value sets and things like that, also concept maps in order to translate one concept into another. And we can define our own operations. We can define search parameters as FHIR resources, structure maps in order to relate two structures to each other, so you can map between structures. And then miscellaneous types of conformance resource. You see the capability statement here, implementation guide. All of these terms you will hear during these dev days, and you will have separate talks about several of these types of conformance resources. So, for example, you will be able to see some terminology sessions as well. There's more about implementation guides later on. And I've got a small overview of other sessions that come after this one at the end of these slides. So a structure definition, that's the definition of the structure, and you will see that FHIR resources and data types are defined in the structure definition as well. Those structure definitions, they contain element definitions, and within those element definitions you can say what kind of type to use for a certain field in the structure, what the cardinality of that field is, etc. We use these structure definitions to describe the FHIR specification, so you will see that the FHIR core standard is described inside structure definition resources, but you can also use them to create your own profiles and create your own extensions. So as I said, it's important to have these because then you can publish them to a repository. You can use them as a base for tools like validation or a profiling tool if you have that. And then, well, because they're computable, that's a really nice thing to have. Operation definitions. If you know about FHIR, you know that you can do RESTful calls to a FHIR server, right? So you've got a standard type of RESTs, like getting some resources, posting resources, updating resources. And FHIR also defines some operations in order to do more with a call, because just retrieval and storage, that's usually not enough. You sometimes want some process to be performed as well. And that's where you use operations. So you will see that in the FHIR specification, you can find operations that are predefined for you. But in your own use case, you might encounter that you have the need for a different kind of operation. And then you just create an operation definition in order to indicate what kind of operation can be performed in your use case. Of course, you still need to implement that as well, but this is the description of it, and because you have the description, you can then tell other people that, well, this is what my system is capable of. Or if you want to connect to my use case, you need to implement this in order to be able to connect to us. Search parameters as well. If you look at the FHIR specification on each resource type page, if you scroll all the way down to the bottom, you will see that there's a search parameter table. Those are the standard search parameters, and they just define what you by default can search on. You can choose whether to support them or not on your own system. So that's a kind of constraint. You can restrict the amount of search parameters on your own system that you support. But you can also have the need to have more search parameters added to your system. You do that by creating your own search parameter definition. Then, if you have that definition, you can integrate that into your system and also show that you support that particular extra search parameter that you've defined. Think, for example, if it's important for you to search on the marital status of a patient. I know that's not one of the standard search parameters. You can create your own search parameter indicating that you want to do support for the marital status of a patient. Create a search parameter definition, implement it, and then you're good. A capability statement is used in order to express what your system is capable of. Whether that's a client system or a server system, you can use that. And within the capability statement, you will indicate which formats you support, which resource types you support, which certain interactions, so there's a list here, so that's what you define, which interactions on the resource types you support, because you might have a post interaction or create on certain resource types, but not on others, and you might be able to search on certain resource types, but not on others. All of these capabilities are expressed in a capability statement of your system. If you use or create your own FHIR RESTful server, it's mandatory to create such a capability statement on that server. If you want to call yourself FHIR RESTful, then you'll have to be able to supply this capability statement on request. But this also indicates, well, everything that you can support. You can also use it to describe requirements. So a FHIR RESTful server needs to be able to give you this information when you request it, but in your implementation guide, in your whole use case description, you can also say, if you want to connect to us, then this is the list of capabilities that your system must have, and you describe that with capability statement resource as well. So it can go two ways. As I said, the structure map resource type is used to define the relationships between two structures. And if you have a structure map like that, you can then use that as a base for transformation of one structure to another. Of course, that takes implementation as well. And we have a nice presentation about our FHIR mapper that we have created at FHIR later on during DevDays. So that's one of the presentations that will be shown on my last slide. I mentioned implementation guides. An implementation guide can just be a document describing your use case, describing all of the extras that you've added to the FHIR specification or the constraints that you've made. And you can just do that on your own website or in a document, create a PDF out of it, whatever you want. But FHIR also has an implementation guide resource. If you use that, then you have your implementation guide again as a structured thing. And with that structure, you can then use something like an implementation guide publisher in order to take all of the information in this implementation guide resource and create a website out of that. This implementation guide resource can point to the other structures that we've seen, so the structure definition, but also the other conformance resources I've mentioned. And of course, next to that, you can also have HTML pages, text files, markdown pages, etc., to point to in order for the implementation guide publisher to take that all into account in order to generate an implementation guide that humans can view. So as I said, the FHIR core spec is defined in structure definition resources. That's usually our leading thing. So even though there are still schemas and schematrons available if you want to, the structure definition contains the complete definition of a FHIR resource. So you will find all of the core FHIR data types and all of the core FHIR resources in structure definitions. And also, as I said, the predefined operations are in operation definitions, and you will have search parameters there as well. Plus, if we're looking at a terminology for coding, then you will have existing code systems and value sets in the FHIR standard specification. All of those structures, all of those resource types, you can create them yourselves as well. So we will use the standard structure definitions for the resource and data types in order to make our own profiles and extensions. But you can also create your own operations, search parameters, your own value sets and code systems if you have your own sets of codes. So, well, we'd like to eat our own dog food, so that's what this picture is about. If I'm talking about conformance type resources, all of the previously mentioned ones, I usually also say something about canonical URLs. Each of those conformance resources gets a unique identifier in the form of a URL, and we call it a canonical URL to indicate that that's the unique thing for that particular conformance resource. The structure definition will have a canonical URL because it's a mandatory field on structure definitions. Some of the other conformance type resources I've mentioned do not have this field as a mandatory field, but I always say you should fill it in. The author of the conformance resource will think about this canonical URL. Usually it will take on your own domain and then some form of structure definition plus some kind of ID behind it. And of course, in this case, you will see the canonical URL for the patient resource type. So the hl7.org/FHIR, of course, then structure definition, because that's the FHIR resource type I'm using, and then an identification for it. If I move a conformance resource to a different server, you can know about FHIR technical IDs. It can get a new technical ID on that other server. So if it's in my server in the EU, it could have technical ID 42, etc., etc. And the URI to retrieve it from my system could be something like this. But That's just the technical thing to get it from my system. The real identifier, that will be the top one here. That's my canonical URL. And of course, because that canonical URL will be the same, no matter what server you put this conformance resource on, you can search on that value. So you always, if you look for a conformance type resource, you always search on the URL. If you have this canonical URL, you can search on it and then retrieve it from whatever system it was stored on. Of course, you will get this technical number somewhere in the data as well, but well, for me, that's not the important one. The canonical URL, that's the important one. So if you're going to do profiling, think about this canonical URL. Think what kind of domain you can use in your organization, and give it a nice name. So in FHIR, we like to make things human readable. So in this case, you can see from the canonical URL that this is probably some kind of patient structure, right? Because I've put that in the name. I'd like to do that always, not just put some random string or number there. Make it something that people can look at and say, oh, that's probably about that. So profiles can be used to define constraints on existing FHIR core data types, FHIR core resources, but they can also be used to constrain other FHIR profiles. Sometimes profiling, the term profiling is also used to mean creation of an implementation guide or creation of a conformance package where we have all of the resources together. As I said, you can derive your profile from the base, from the core standard, but you can also derive your own profile from another profile. And in that way, we can get layered profiles where you will have a small number of core profiles. All resources will conform to the core profiles, because even if I create a profile on a patient and I send you a patient, it will still be a FHIR patient. You will still have to conform to the core. And then, of course, you will have these layered profiles, each deriving from another and getting more and more specific. The core structures have to be generic enough to be reused throughout the world. And then, of course, within your own nation or within your own region, you will constrain that down, make restrictions on it, and make it, well, less flexible, but more useful in your own use case context. And in the end, as you can see, well, all resources will conform to the core profiles, and just a number of resources will conform to the lot of organizational or use case specific profiles. All the work for profiling will be done with structure definitions. So as I said, in a structure definition, you will have to define this canonical URL. That's the metadata about the structure definition. Within the metadata, you will always also add a title, author information, the date, a version, etc., etc. But then the real work will be inside of the element definitions. So for each of these fields that you see here, you will have an element definition within the structure definition that tells you about the name of this element, about the cardinality of this element, about the type of this element, mappings of that element as well. So all of that information will be within the element definition. You can also use these element definitions and add extra constraints to it. So usually when you start out, you will just take a look at cardinality, make some fields mandatory that were optional in the specification, things like that, perhaps limit the number of types that you can choose. But you also have something called a FHIR path, and a FHIR path expression can be used in order to make more complex constraints that go beyond cardinality or go beyond terminology bindings and things like that. So in this case, we have the top example here that we can say, okay, we can check whether there's a name in the patient that is a given name and it is set to Wouter. Well, if that exists, this expression evaluates to true, and that will mean that, well, my validator can check that, and if it evaluates to true, then everything is okay with that resource. I will have a FHIR path session on Friday as well if you're interested in more complex constraints. Once we've created profiles, of course, we need a way for resources to be able to indicate conformance to that particular profile. So in this case, you see that I have an observation resource with some data inside. And what I have to do is I have to label this with a profile tag that's within the metadata of a resource. And this profile tag will be set to a canonical URL. Again, that canonical URL, that's why it's so important. You will need to indicate conformance, and you do that with the canonical URL. So in this case, in the metadata, I will say, okay, I conform to that particular profile that's listed there. Then, of course, we could reach out to this domain and see if we can find a FHIR server in order to get that profile from it, so we can do validation and things like that. So we could try and resolve that and then use that structure definition that we get in order to validate if it's correct. Because this is just a claim. I'm claiming to conform to that particular profile, doesn't make it true. I could have claimed to be called something else than Mirjam, and you would have probably all believed me because you don't know me. But if you look in my passport, you could validate whether my name is Mirjam or not. In this case, we can try to reach out to this domain, but of course we don't mandate that everyone that creates profiles also has a FHIR server in order to store those profiles on. So what you could also do is make use of a registry. At FHIR, we've created a public platform called Simplifier.net. You will probably hear this name more often these days. And this is a public repository for profiling and profiles and other conformance resources. If something's put on there, you can search Simplifier. Usually for me, that's of course the first thing I do, go to Simplifier, see if I can find that profile on there, and then, well, I'm good to go, because then I can hopefully retrieve the structure definition and use that for my validator. So you could manually author a profile because it's just a FHIR resource, and as we know, we can create FHIR resources by just typing in XML or JSON. But I haven't shown you what a real profile looks like in XML or JSON. It gets complicated real quickly. So you wouldn't want to do that by hand. And we have some tools that we have here. At FHIR, we've created the Forge tool, but as you can see, there's other profiling tools available as well if you want to try them out. And I'm happy to give you a demo of Forge later on. I probably won't have time during this talk, but I'm available to do a Forge demo, and other FHIR people will be there as well. And there's a Let's Build session with Forge on Friday too. So that's a profiling tool, and you can use a tool like that in order to create your own profiles. I would highly recommend using a tool and not manually authoring it. So the other thing that you might encounter real quickly is extensions. Have you heard of the 80-20 rule in FHIR? Who hasn't? Okay, a couple of people haven't. 80-20. FHIR working groups decide what is inside a FHIR resource, the elements, the fields that you can use, right? Those working groups look at an element and then say, is this used in about 80% of implementations or not? If yes, they put it in. If no, they leave it out. And that will mean that you will encounter data elements that you need to communicate in a resource, but they are not there in the FHIR standard. So for example, you see the example here that we have race and ethnicity, which in the EU usually is illegal to register, so you can't communicate that either. So it cannot be in a FHIR resource. But in the US, it's mandatory. So they'll have to have it in the FHIR resource. You'll see that the FHIR standard cannot put it in, because then it wouldn't be useful globally. So they will have to leave this out. but then they will have to have some kind of mechanism to add it back in for those that need it to be in there. So that's where you use extensions. Of course, there are already some standard extensions, particularly for these ones, also for the Birthplace, which is my favorite one, because, well, in the Netherlands, I think every system knows where I was born. And we communicate this data, well, quite often, so we would want to have that in there, but that's not common in 80% of implementations, apparently. I didn't decide that, the working group did, so if you have any problems with what's in there or what's not in there, go to the working group and complain. Fortunately, FHIR does offer you a mechanism, and that's the extension mechanism. So you can create your own extension and then add it to your data. All data that has extensions is still FHIR compliant. So I could send you all a Dutch patient with Dutch patient extensions on it, but it's still a FHIR patient. So you will be able to consume that data, see that there's some extensions you don't know about, well, you just disregard them. That's okay. You use the data elements in there that you do know about and that I sent to you, because that's just a FHIR patient resource still. So, well, yeah, I'm a fan of this mechanism. You can probably hear that from my voice. So if you're going to author extensions, you will also say where this extension can be used. So in creating the extension, you will say, this is an extension that you use on the patient, or this is an extension used for observation, or perhaps on a field within a specific resource type as well. You can extend absolutely everything in FHIR on every level, apart from the top level of bundle or something like that. There's not much that you can't extend. So, well, go and take a look at FHIR resources. Think about what data you need extra, and then you can define extensions on it. One advice here is first look at existing extensions before you create your own, because it's a really nice mechanism, but it also makes for, well, growth of a lot of extensions just popping up everywhere. So I would advise to go to some kind of public repository, check whether that extension is already there. If it's not, you're perfectly free to create your own. But if it's there and you can use it, please reuse it, because, well, why do the work again? You're also going to hear about packages. Packages are a versioned and published set of conformance resources. So all of the types of conformance resources I've mentioned, they can be packaged together in one package. And these packages are based on NPM. There's a session that Graham and Martijn from FHIR will do later today, I think, about packaging. But the important thing is that you can, as an author, you can package it. You say, this is a good set of conformance resources, and we package this. Then other tools can just download that package, and we'll have the complete set of conformance resources that belong together, and also the dependencies on other conformance resources. So, well, if I just base my profiles on the core standard, then of course I still am dependent. I have a dependency to the core structures, and that will be in that package as well. So packages are really nice to have there. Our Forge tool is also able to use packages, consume them, so you can point Forge to a specific package that's on Simplifier. Simplifier is the platform where you store all your conformance resources, and you can also use Simplifier to create a package. So you can just say, okay, this is the set, now create a package. Then it will be on Simplifier, so it will be published, and our Forge tool can then consume it in order to derive from that even further if you need. Well, I've mentioned this Simplifier registry, but there's also an Hl7 Profile Registry as well, powered by Simplifier in the end. So you will have to put it on a Simplifier project, and then you can choose to be in the official Hl7 registry as well. Same holds for implementation guides, so you can use that as well if you have your own implementation guide resource and you want to put that on an official registry. It's also useful to just take a look at these links later on one time and see what's there already. So for example, US Core Profiles implementation guide for that, they are on the official registry as well. As I said, we have the Simplifier platform, which is a public FHIR registry. It does contain all of the standard structures, all of the official Hl7 profiles, and also, well, a lot of other projects by now. Some companies prefer to put them in private projects, so you won't be able to see them, but that is part of the Simplifier platform. But you will also see a lot of public profiles, public projects that are, well, for a part test projects, but for another part organizations that really work with FHIR now and have created profiles for you to view and use if you want to connect to their use case. Who's from the Netherlands here? A couple. You've probably heard of the MedMy project, or you know about Nictis. They have published Dutch profiles on Simplifier in order for you to use if you work for the Dutch market. So then, if you have them on this platform, you can validate examples against those profiles. Simplifier offers you that as well. You could either download the profiles and then validate on your own machine, but you can also upload example resources to Simplifier and then say, okay, I want to validate against those profiles. So, well, it helps you there. And as I said, you can have the packages on there. You can also create implementation guides on Simplifier. So yeah, that was my FHIR plug there. So what's next for you? I've got a list here. So there's today profiling in R4 by Graham. He will tell you what the differences are between profiling in R3 or STU3 and R4. So that could be useful if you have already done some work in STU3 profiling, just want to know what you have to think about when you move over to R4. But also, as I said, there's a session about the mapping language, the FHIR mapper. That's followed by a Let's Build session. So there's first some explanation and then Let's Build, so you can create your own map and transform one structure into another. There's more about the IG publisher I mentioned, the implementation guide publisher on Thursday. More about packages on Thursday. Sorry, that was not today, but Thursday. And then if you're interested in the Dutch profiles, then on Friday there's a session followed by Let's Build as well. And as I said, using Forge is on there too. But if you can't wait until Friday, please just walk up to a member of FHIR and say, hey, can I have a Forge demo? Well, I still have about 7 minutes. So this was my talk. I'm going to hand over to you for questions in a minute, but I just want to show you hopefully I didn't try this out yet, but I want to show you the Simplifier website. Let's see if I can get it up there. As you can see, I'm not logged in. There's a login button. I do have a login if I wanted to. I could find a login, but I want to show you that this is a public platform, so anyone can just go out to Simplifier, in this case through the website, but it also has a programmatical API, so you can also reach out from your programs to Simplifier. You don't need an account, and you can search all of the public profiles. So what I usually do is something like, well, I'm Dutch, so I'm interested in the anal core patient. I could have some other more textual searches as well, but you can see that whatever I want to search on, I can fill it in, and then you get a list of these, well, profiles in this case. So let's just click on the Dutch patient here. And for those of you familiar with the normal FHIR resources and the pages for that, you will see a similar page on Simplifier with the same tree structure that you are probably familiar with. And in this case, well, I'll just click on the hybrid view because this is the complete picture. But if I click on the hybrid view, everything that's still in black is something that they've changed something about. either a description, changed cardinality perhaps, changed some bindings, things like that. So you can see that there are some differences. Everything that's still gray is the base specification still. So, well, as you can see, instead of the normal FHIR address, you see NL core address here, so they've changed the data type. NL core address, by the way, still is a FHIR address, of course, because otherwise I wouldn't be compliant to the core spec. Well, you get the idea. You can change data types, can profile those data types as well, and then connect them into your profile there. Just a small look into what this looks like in XML. You will see, well, some basic metadata, and then if I scroll down further, as you can see, this is already quite a lot. You will see that there's something called differential on my screen now. And then for each of the elements that are changed, they will be listed in this differential. You will see the path, and then you will see all of this information that they have changed on the profile that they based this one on. And if you would scroll down further and further, you will see that this gets really complex. It doesn't look too complex, but it's really easy to make mistakes if you would have to do this by hand. So that's why I said use a tool to do that. So that's the end of my talk. Are there any questions?
If you reuse existing extension, how you handle a problem that the extension is not in your governance? I mean, the author of the original would update or change it.
Yeah, so if you reuse an existing extension and the author of that extension, well, you're not the author yourself, right? So the author could change that. If the author changes it and it's not in a backwards compatible way, it should be a new extension, so the author should take care of that. And another thing that you can do is use a particular package. So you can say, okay, this is version 1.1 of this set of conformance resources. The extension is part of that. I'm using version 1.1. I'm using that package. So you will still, your code will still depend on package 1.1. And if the author creates a 1.2, then it's of course up to you to see what the implications would be if you would update to that new version of a package. But you can still choose to keep continuing on 1.1. Yeah?
Does that imply like when the package is published, it should never be changed?
Yes, that implies that packages are published and then they are there. They won't change. If you would change a package, it will just get a new version. Yeah. Any other questions?
You mentioned the canonical URL is globally unique, but it misses version information.
Yes. No, I can't. I can't elaborate on versioning. A good person to talk to about that would be Martijn from FHIR or Graham, and they are going to discuss versioning with packaging as well later on in their session. So that would be. There's been lots of discussion, and I personally just don't know what the answer to that is, but they will be able to give you an answer on versioning. Yeah, so the question is if you are not interested in all of the elements in a resource and you don't want to forbid them, scratch them out, so any client can still connect to your system, could we indicate if that we are not interested in that? It's usually more the other way around. So I would say in this case, yes, take an open approach to modeling and not a closed one, because closed one is less flexible. And if you have lots of clients connecting to you, then the open approach is good. But what you would do is either, well, make mandatory the elements that you need to have. You also have something called must support. That's just a flag on an element that says, if you have this data, provide it to us, or if you can do something useful with it, do that useful thing with it. So it's not that you can say we're not interested in this, but you can indicate that you're more interested in other elements by using the must support flag. Yeah. Okay.
You had mentioned that reporting a patient's ethnicity is illegal in Europe and mandatory in the US. Does that apply just to electronic medical records, or?
No, it's illegal in every system in the EU to have the race or ethnicity on the data. So yes, on all medical records, but also on other areas in everywhere in electronic data sharing. I don't know about the US specifically, whether that's mandatory everywhere, but.
I'm a doctor in London, and I've never heard of anything like that.
Okay. Well, there are EU regulations. At least I know that in the Netherlands. This was a slide, by the way, by my colleague. So I can't claim that I know it's true, but I do know that in the Netherlands it's forbidden. After World War II, we forbid that to be on any system. So, yeah. Yeah.
Do you know how it's handled? Because race is important, for instance, for A-care.
Yeah, so race is important in research as well, I know. I don't know how that's handled. That would be up to law and rules and regulations. FHIR can't change that. It can only give you the opportunity to make extensions to indicate something. But if you're not following law, you'll have to be careful with that, of course. Okay, and any other questions? I'm here for the full 3 days, so if you have any questions afterwards, send me a message through the app or find me somewhere, and well, please come up to me and I'll help you further. So thank you for your attention.